Good afternoon, class.
Good afternoon, sir.
Today we want to discuss trigonometry. Today's video we want to discuss trigonometry. For trigonometry, basically, you need first to understand what we call the basic trigonometric ratios. We have so many trigonometric ratios, but basically we have three. So these three, we call them sine, cosine, and tangent. For the basic trigonometric ratios, there are three. We have the sine, the cosine, and the tangent. Alright. Now, these trigonometric ratios, we want to define them. We want to display their ratios. But we can only define the basic trigonometric ratios with a right angle triangle and with a given angle. It cannot make a sense if we only define sine. It cannot make a full sense if we can only say what? Cosine and tangent. But with a right angle triangle with a given angle, that one can give us a complete sense. It will make a complete sense. Now let us say here is a right angle triangle. Remember, for a right angle triangle is one in which one of the interior angles is exactly 90 degrees. So here is a right angle triangle. Let us say we have a given angle here as theta. So this one is a Greek alphabet that we call theta. So this theta can represent any angle. It can represent angle 30 degrees. It can represent angle 60 degrees. It can represent 48 degrees. It can represent every possible angle. Now, but before ever we define the sine, the cosine, and the tangent as the three basic trigonometric ratios, we need first of all to identify the sides of a right angle triangle with a given angle. Now, let us pay attention here. Now, if we have this one, now this angle is acute, it is less than 90 degrees. This one is less than 90 degrees. This one is less than 90 degrees. So it tells you that this triangle, none of its interior angles is exactly 90 degrees. That makes it what? A non-right angle triangle. It is not a right angle triangle. But for this triangle, one of its interior angles is exactly 90 degrees. That makes it a right angle triangle. So only with a right angle triangle and a given angle, let us say theta, we have the right to define the sine, the cosine, and the tangent. Alright. Now, but before we continue defining sine, cosine, and tangent, we first need to identify the sides as a result of what? The given angle. Alright. Now, since this theta is the given angle, it is understood that in a right angle triangle, any of the three sides that faces the given angle, any of the three sides that faces the given angle, that side is what we call the opposite side. And this is the opposite side. This side is what we call the opposite side. The reason being, it is the side that faces what? The given angle. Let us assume that the given angle is here. This time around, let us say beta. Let us say beta. The fact that this one is a right angle triangle, 2, there is a given angle we call beta. So any side in a right angle triangle that is facing the given angle, that side is what we call the opposite. So instead of the previous case, as here being the opposite previously, now beta as the given angle, this is now what? The opposite side. I hope that was understood. So back to where we started. Now we want to maintain theta as the given angle. So since theta is the given angle, and that side that is facing the theta is what we call the opposite side. Now we have two sides remaining. For the remaining two sides, there is also a side that is between the given angle and the right angle. That side that lies between the given angle and the right angle is what we call the adjacent side. So this side is the adjacent side. How? Because it lies between the right angle and the given angle. Now it remains only one side. This one side is what we refer to as the hypotenuse side. The hypotenuse side is the side that we regard as the longest side in any right angle triangle. This side is the hypotenuse side. How do we identify the hypotenuse side easily? It's by locating what? The right angle. The right angle is faced by this side. So any side that is facing the right angle, that side is what we call the hypotenuse side. Hypotenuse side. Alright, so this one is understood. So if I want to make it more clear, let us say we have here a right angle triangle, and here is the given angle. The given angle. This is the 90 degrees, the right angle. So the fact that this is the given angle, we can say here is our opposite side. The fact that this is the side that lies between the given angle and the right angle, this is what we call the adjacent side. And this is definitely the side that is facing the 90 degrees. This is the side that is facing the right angle. The right angle is what we call 90 degrees. So this angle is what we call the hypotenuse side. So with the same triangle, we can have a triangle like this. Yes, this one of course is similar to this. But instead of this one being the given angle, we now want to say this is what? The given angle. So here being the given angle, we cannot call this one again the adjacent side. The side that is facing the given angle is the opposite side. The side that is facing the given angle is the opposite side. The side that is facing the given angle is the opposite side. So here, how it becomes the opposite side. The side that lies between the given angle and the right angle is the adjacent. The side that lies between the given angle and the right angle is the adjacent. So here again, the side that lies between the given angle and the right angle is the adjacent side. And the hypotenuse side remains the side that is facing the 90 degrees. So here is the hypotenuse side. So that one is well understood, I hope so. So back to our point here where we started. The adjacent side lies between the given angle and right angle. The opposite side, it is facing the given angle. The hypotenuse side, it is facing the 90 degrees. Alright, now we want to define these trigonometric ratios. But these trigonometric ratios, when we apply them in mathematics, we don't want to write sine in full. Rather, we say what? We say sine, S-I-N. Though if you are not aware of the trigonometry, you may want to call this one as sin. But in trigonometry, this one is the short form for the full name sine. So if we say, according to the given angle theta, this is sine theta. But in short, it is written this way, sine theta. So this is cosine theta, provided if the given angle is theta. If the given angle is alpha, we say cosine alpha. If the given angle is beta, we say cosine beta. So in short, for the cosine, we say cos. So instead of cosine theta, we say cos theta. So here again, tangent theta. But the short form, we say tan theta. So sine, cosine, and tangent, these are the three basic trigonometric ratios. In short form, when applying them in solving mathematics problems, we say sine, we say cos, we say tan. So if the angle we are using is beta, sine beta, cos beta, tan beta. If the angle being used is alpha, sine alpha, cos alpha, tan alpha. But we are using what? The theta. So we can say sine theta, cos theta, tan theta. Alright. So now we go to the definitions now. It is understood in mathematics that sine of any angle, be it theta, be it alpha, be it gamma, be it whatsoever. So sine of any angle is equal to the opposite side of that right angle triangle over the hypotenuse side. So sine of any angle, sine of theta, sine of beta, sine of theta, sine of alpha, sine of 30 degrees, sine of 60 degrees is equal to the opposite side over the hypotenuse side. So now we come to what? The cosine. Cosine of any angle, let's say alpha, is equal to the adjacent side of that right angle triangle with the given angle over the hypotenuse side of that particular right angle triangle. Now we come to tangent. The tangent of any angle, regardless of the given angle, be it angle 30 degrees, angle 70 degrees, angle theta, angle alpha, the tangent of any angle is equal to the opposite side of that right angle triangle with the given angle over the adjacent side of that particular right angle triangle again. So in summary, sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, tan theta is opposite over adjacent. Now, let us create a way that we can be able to remember this, at all times. So what do we do? Now, the fact that this is sine, this is opposite, this is hypotenuse, we can say SOH. We can use the acronym SOH. That is, sine of an angle is opposite over hypotenuse. Now, cosine of an angle is CAH. So this implies CAH. That one is very simple to remember. CAH is what? The car. Yeah, of course, we know car is CAR, car. We all know car, right? You and I want to drive cars. So this one is car. But here I want to use the acronym CAH. That is, cosine of an angle is adjacent over hypotenuse. Now the last one here is tangent. In short, we say tan. So that is T, that is O, that is A. So we can have SOH. That is, sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Tangent of an angle is opposite over adjacent. So far, these are the three basic trigonometric ratios. These are the three basic trigonometric ratios. So thank you for watching. Don't forget to like, don't forget to share the video. Thank you very much. Bye-bye.